over the chapter 14 on oxidation reduction. Now, the chapter starts off with lots of definitions of oxidation reduction. So I've just summarised them here. We've gone through these in school. The first two you would have had in junior cert. So oxidation is the addition of oxygen. Reduction is the removal of oxygen. Oxidation is the opposite then. Removal of hydrogen. Addition of hydrogen is reduction. Now, oil rig, remember that? Oil rig. Oxidation is the loss of electrons, reduction is gaining of electrons, and then in ON, remember oxidation number. If there's an increase in the oxidation number, it's oxidation, and if there's a reduction or a decrease in oxidation number, then it's reduced. The other definitions then, you need to be able to define oxidizing agent. Remember, the oxidizing agent is itself reduced. So it's like an agent for something, for oxidation in something else, okay? A reducing agent, of course, is a substance which brings about reduction in something else. The reducing agent is itself oxidized. So we would have gone through that. And on page 104 of your revision book, there's a table there, table 14.2, which talks to you about different oxidizing and reducing agents. You should know an example of, or actually maybe two examples of oxidizing agents and two examples of reducing agents, okay? Now, the other definition then that you're supposed to know is oxidation number. And this is quite important. So it's the charge that an atom has or appears to have when electrons are distributed according to certain rules. Now, you see, it's fine if the substance, if the compound is ionic, it's grand. Because if it's something like NaCl, then we know that the Na is plus, the Cl is minus. So we know that the Na has lost an electron, and loss would be oxidized. So we'd know then that that was oxidized. Cl minus tells us that the chlorine has gained an electron. So we would know that the chlorine had been reduced. The problem is with covalent compounds like water, where there is sharing of the electrons. You see, you can't say that the one atom gets the electron and the other atom loses the electron. So for the purpose of oxidation numbers, we assume that the bonding is like ionic. So, and then we go with electronegativity values. So because oxygen is more electronegative than hydrogen, we assume that the electrons go to oxygen, okay? And that the hydrogen's losing electrons. Now remember that oxygen would have 6 electrons in its outer shell itself. So it's actually gaining this one and this one. So that's why we say that it's -2. The hydrogen is losing its electron here, and this hydrogen is losing that electron there. So that's +1 then. Each hydrogen atom is losing 1 electron. So we assume that the bonding is ionic for the purpose of assigning the numbers, because otherwise we don't know, we can't be doing when you know, if you're thinking of it being shared, you know. Now the next thing we would have gone through in school then, quite with the rules for assigning oxidation numbers. So like rule number 1, if it's not bonded to something else, it's 0. So like watch the ones that are diatomic. So like chlorine there, that's a chlorine molecule. Chlorine is bonded to another chlorine. It's not bonded to something else, something different. It has to be bonded to something different if it's going to have an oxidation number. So if you see iron, if you see oxygen, if you see chlorine, oops, that's a Cl, if you see hydrogen, they're all 0, okay? The second one then is that the charges of the oxidation number of the element is the same as the ion. That just means that if something is in group 1, then it's going to have a +1 charge. Group 2, +2. Group 7, -1. Group 6, -2, okay? Now, the exceptions. Oxygen is normally -2 because it's in group 6, right? But if you see, watch for the two exceptions. If you see H2O2 or OF2, you were straight away thinking this is an exception. Now, rule number 3 says that the numbers have to add up to give you 0, okay? So hydrogen is +1, oxygen is -2. Just pretend we're saying oxygen is -2. Do our multiplication, -4. That doesn't give me 0, that gives me -2. So because there are 2 oxygen atoms there, then what we have to do is we have to say, again, hydrogen is +1 and that the oxygen is -1. So that when we multiply, then you have +1 times 2 is +2, -1 times 2 is -2, and they add to give you 0. So watch for hydrogen peroxide, where oxygen has an oxidation number of -1, and the other one is OF2. Fluorine is more electronegative than oxygen, okay? So if we draw fluorine OF2 there, now we could fit in the other 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right. So if we fill in fluorine is more electronegative. Fluorine is the most electronegative. So it's like fluorine is taking the electrons. So the electrons are going that way. So it's like you draw a line across there. Oxygen is losing 1, 2 electrons. If it's losing electrons, it's going to become positively charged, and each of those fluorines is gaining 1. That fluorine atom is gaining this electron, this fluorine atom is gaining that electron, okay? So plus 2 if you see OF2, minus 1 if you see H2O2. That comes up a lot in the question 4s, the short questions, okay? Rule 5, hydrogen is normally plus 1, except if hydrogen is bonded to a metal. Now, why metals in particular? Because they are less electronegative. So something like if you saw NaH. Now, if you look up sodium, in the periodic table, it's 0.93. Hydrogen is 2.2, which means that hydrogen is going to take the electron. It's more electronegative, okay? Now, don't overly worry about these last few rules. I think you're going to spot them. Like the minute, if they ask you to assign oxidation numbers to NaH, and you say, you carry on as normal, and you say to yourself, oh yeah, I'm going to X then. Well, actually, you wouldn't probably X the sodium. You'd probably say to yourself, sodium is in group 1, so sodium is plus 1. Oh, hydrogen is always plus 1. Oh, you've got a problem there, haven't you? So then you say to yourself, oh, this is one of the exceptions. Hydrogen is not plus 1 there. Hydrogen is minus 1. And how will you kind of like explain that to yourself? You're going to say that hydrogen is more electronegative, so it takes the electron from sodium. Sodium is plus 1, hydrogen is minus 1. Okay, so again, normally hydrogen is plus 1, except if the hydrogen is bonded to something which is less electronegative. Then the sodium is losing electron, becoming plus 1, and the hydrogen is gaining the electron, becoming minus 1. Okay, rule number 6 then says that the halogens normally have an oxidation number of minus 1. That's because they're group 7. But you see, again, if you have something where you have a halogen bonded to an element that's more electronegative, like for example, oxygen there is minus 2. I know that oxygen there is minus 2 because it is not one of my 2 exceptions where oxygen is not minus 2. So in every other case, oxygen is minus 2, except for the OF2 and the H2O2. Then, so you call chlorine X. Then, oh yeah, what I was getting at there was that, imagine you didn't kind of spot it, you didn't realise it, and you think, oh yeah, chlorine's in group 7, so that must be minus 1. Straight away you see that can't be, because the sum of the charges have to add to give you 0. So you're saying, oh, must be my exception, rule 6. Halogens normally are minus 1, but if they are bonded to something which is more electronegative, oxygen is more electronegative than chlorine. Multiply out then, so 2x minus 2 is equal to 0, 2x is equal to plus 2, so x here in this instance is actually plus 1, okay? All right, and then just the last rule 7 there is be careful if there's a charge on the ion, you know, so if it's minus, if it's a nitrate ion like that, X the nitrogen, again oxygen is always minus 2, it must add to give me minus 1. So X there then minus 1 plus 6, so X comes out at plus 5. So just watch that if it's a complex ion, that the sum of the oxidation numbers add to give you that charge, whatever that charge is. Okay, now there are the rules. Now just quickly, I think we were actually all okay with this, but if you got something like, and again in question 4 normally they might ask you something like this, to get the oxidation state of the sulfur. X the sulfur, oxygen is always minus 2, except again remember OF2 and H2O2. Then you multiply. Don't forget now this has minus 2 charge, so 2x then is equal to plus 4 when I bring that over. Oops, so you're just going to say then divide across by 2. X is equal to plus 2 there in that instance, okay? So you can work those out. I think we were actually not too bad with those. Now, the next thing I just wanted to quickly do there now is do an example of balancing an equation, okay? So this was an exam question. I can't remember what year I got it from now. But look, I'll just write it down in H2O there. Now, we have rules in your notebooks as to how to start off balancing equations. So the first one we said was assign oxidation. Oops, I won't bother writing that in actually. Assign oxidation numbers to everything. Copper on its own, not bonded to anything else, 0. X the nitrogen, because I'm not sure, I know that the oxygen is minus 2, so x minus 6 is equal to minus 1, so x is equal to plus 5. The hydrogen they're telling me there is a plus 1, the copper they're telling me is a plus 2. Similar there, look, work that out. X minus 4 is equal to 0, so x is equal to plus 4, and always water plus 1 minus 2. So that's that one. Then we pulled out what was being oxidized and what was being reduced. So how will you know what's being oxidized? Well, what has gone up? What has there been an increase in oxidation number? So you can see that the copper has gone from 0 up to +2. So the copper has been oxidized. Now, what does oxidation mean again? Loss of electrons. So that means the copper atoms have lost 2 electrons because it's copper +2. Okay? And what has happened? What has been reduced? I mean, the nitrogen, the N +5 has gone down. So we're going to just write minus. Now, reduction, Rig, means that it has gained. So +1 electron, and it's gone to the NO2. The third step then we said was we had to balance the electrons. You can't have a situation where you have something losing 2 and another species gaining 1. How will I balance that? Multiply this by 1 and this by 2. Insert your ratio, okay? So I'm putting a 1 in front of the copper. So I'm just going to rewrite the copper Cu plus, I have to put a 2 in front of the NO3 minus, okay? And then I'll just rewrite the other side of it there for a second. And then after you insert the ratio, then you need to just balance your atoms after that. So you say to yourself, I've got 1 copper here, I've got 1 copper there. I have 2 nitrogens here and I've only 1 there, okay? So I'm going to put a 2 in front of that to balance the nitrogens, 2 nitrogens and 2 nitrogens. Do the oxygen next always, and lastly, the hydrogen. 2 times 3, 6 oxygens there. Now look, I have 2 times 2, that's 4, and I've 1 here. So if I put a 2 in front of that, that's 2 oxygens, and 4 is 6, and 6, so that's balanced. And then the hydrogen, 2 times 2 is 4 hydrogens, so you put a 4 in front of that. And remember then, the nice thing about these, you can check to make sure that they're balanced. Not, now, what's the charge on this? -1, 4. Oh, sorry, that's -2 because there's 2 of them. Look, so 2 times -1 is -2. 4 times +1 is +4. And over here, I have a +2. No charge there, no charge there. So +2 equals +2. So that's perfect.